All right, hello you guys. This is an exit ticket recap video for our online week 4. As you can see on the slide here, we've got some clear points. I was happy to see that a lot of people said measured versus manipulated variables was a clear point. I was hoping that would be the case. And quite a few people said independent groups versus within groups designs was also clear, but some people said that was confusing as well. So let's go ahead and jump right into the muddiest points. That's what y'all are here for. All right, so here are the muddiest points. You can see I've put red boxes around the ones that we are going to talk about, and that's based on what was most common as well as what people specifically requested videos on. So these are the things we're going to talk about. You can see here that by far the muddiest point was pros and cons of independent groups designs versus within groups designs and how to design experiments with those. 20 people requested that. A couple other things, confounds, pretest, post-test versus post-test only, measured versus manipulated variables, and then systematic versus unsystematic variability, and then a couple other things that only one person said or that videos were specifically not requested for. So let's go ahead and jump into the first most common muddiest point. Okay, so let's jump right into the most common muddiest point, and that was pros and cons of independent groups designs versus within groups designs, as well as how to design experiments where you turn an independent variable into either independent groups or within groups designs, like in activity number 2 in our week 4 module. All right, so first off, pros and cons of each of these design types. With independent groups designs, remember what's happening in an independent group design is that participants are only seeing one condition. That's why they're independent groups. The groups of participants that you have in, say, your 2 or your 3 conditions or however many conditions you have, the groups that you have are different people. They're independent from each other because they're not the same people in those different groups. That's why it's called independent groups designs. The main pro of this is that it avoids problems within groups design. So it avoids order effects, which can be a big issue with within groups design. That might seem weird that the main advantage of an independent groups design is that it avoids the problem of the within group design, but you'll see that these two designs kind of complement each other like that. One avoids the problems of the other, and that's kind of how these work. So the main pro is that it avoids order effects because you have different people in your 2 conditions. They're not seeing both of them. They can't modify their responses. You know, they don't know what it is that you're studying, all that good stuff. It avoids those kinds of problems. But it does have cons. So it requires more participants because you have different people in your 2 conditions. You have to have more participants to do appropriate statistical analyses. The reason you need more participants is because you have more unsystematic variability because you have different participants in your different conditions. So that means if you think about the postable study, I'm going to use that a lot in this recap video, but think about that postable study, right? The small versus large bowl, and they're looking to see, does bowl size impact how much pasta people eat? You have different people in those 2 conditions. So some of your people in the small bowl condition, some of your people in that condition really love pasta, some of them really hate pasta. Some of them ate recently, so they're full. Some of them are starving, right? Some of them are athletes, they eat a lot, period. Some people are trying to eat less. You've got all those different types of people in that small bowl condition, and you have all those different types of people also in the large bowl condition. So it's creating unsystematic variability. How much people are eating is changing randomly because some people are hungry, some aren't. Some people really love pasta, some people hate pasta, right? That's happening in both of your conditions, so you have more unsystematic variability. Remember, unsystematic variability, that's expected. We account for that in our statistical tests. When you take statistics, you'll probably hear more about that. What you're doing with inferential tests is you're trying to see difference between condition divided by unsystematic variability. So you're taking that into account when you are doing statistical tests. But because you have more unsystematic variability because there's different people in your conditions, then that means you need more participants to do those analyses. So that's the pros and cons of independent groups designs. Within groups designs are where your participants are seeing all of the conditions. So that's different from independent groups where they're only seeing one condition, right? But in within groups designs, they're seeing all of the conditions. And there's pros and cons of this design too. So pros is that it requires fewer participants, and the reason it requires fewer participants is because you have less unsystematic variability, because you have the same participants in your conditions. So the type of people you have in condition 1 is actually identical to what's in condition 2 because it's literally the same people. So if you were going to do that postable study and have people first eat from a small bowl and then eat from a large bowl, you're getting rid of a lot of variability between those 2 conditions. conditions because it's literally the same people. So you'll see how much a pasta hater eats with the small bowl versus the large bowl. It's the same person. So you're seeing just the difference in condition for that one person. So there's less unsystematic variability. Each person is their own control. That's what we say about this. Because they are the same people in the different conditions. So that's a pro. It means you need fewer participants in order to run your statistical analyses. You have less variability to worry about because it's the same people. But there are big cons too. So for one, it requires counterbalancing. If we were going to do that pasta bowl study as a within groups design, and everybody first eats from the small bowl and then eats from the large bowl in that order, that's going to create problems, right? Especially if they're doing it right in a row, because they will all have just eaten a small bowl amount of pasta and they're not going to be as hungry for the large bowl. So they're going to put less on their plates. But it's not because a large bowl makes them eat less. That would be the causal claim we might want to make here, that large bowls, to explain that finding, that large bowls are making people eat less. But you can see it's not the large bowl making them eat less. It's the fact that they just ate with the small bowl. That's the real cause of that data. So it requires counterbalancing to solve that problem. So with counterbalancing, that means that some people are going to do the small bowl first and then the large bowl, and some people are going to do the large bowl first and then the small bowl. That's counterbalancing. You're just switching up the order in which people see it so you can make sure that you don't have an order effect. So you have to counterbalance, but counterbalancing is pretty easy. It's not that big of a con. But you have other bigger cons within groups designs. One is the potential for demand characteristics. So remember, demand characteristics, that's when participants are onto you, they know what it is that you're doing, and they might be modifying their responses, either to help you or to hurt you. You can imagine that if people are in this pasta bowl study and they first eat with a small bowl and then eat with a large bowl, or vice versa, counterbalancing, they're probably going to be able to tell that the bowl size is something that you're changing as the researcher, and they're going to guess that what you're trying to find is whether bowl size impacts how much you eat, right? They're going to know that that's what you're doing. Whereas in an independent groups design, they only ever see one condition. So here's my cat again. So if they only ever see one condition in the independent groups design, then they don't know what it is you're studying. They have no idea bowl size mattered at all. They're just going to give you their natural responses, right? But in within groups designs, if they know what you're studying, they can see what you're manipulating. Now they know what you're doing, and they might change their responses. Maybe they think, oh yeah, that's a reasonable hypothesis. I'm going to help them out to prove this hypothesis. And that's an issue, right? Because we don't want them helping us or hurting us. We just want their actual natural responses. So that's a big potential disadvantage of within groups designs. If we think that if people know what we're studying, that that's going to compromise the data quality, then that would be a reason to not use a within groups design. Lastly, sometimes within groups designs are impossible. So I know my video is cutting this off a little bit, but I think the example in the textbook was a really good one of bike riding. You're trying to compare two different methods of teaching someone how to ride a bike. You literally can't do that as a within groups design, because once they've been taught one way, now they know how to ride a bike. You can't erase that knowledge, take them back to scratch, and teach them the other way. You can't use the same participants in multiple conditions there. It would give you crap data if you tried to. So sometimes you have to use independent groups designs. All right, so this idea of pros and cons of both, as a researcher, we're really making a decision about whether we think that there are more pros or more cons for a certain design type. So we're always kind of looking at it and saying, which pros do I want to emphasize here? Which cons are going to be a big problem for me? And then we're deciding which one to use. So whether one is better than the other, that's not the case, right? It's not that one's better than the other. It's that there are pros and cons of each, and as researchers, we have to decide which cons we're willing to live with and which pros we want to have in our study. All right, now the second part of this was how to design experiments like activity 2. I know this can be a little confusing, but you just want to think about it like this. With an independent groups design, what you're doing is you're randomly assigning participants to see only one condition. That's it. That's all you're doing with an independent groups design. That's all you're doing when you're designing an experiment with that, is that you're randomly assigning participants to see only one of your independent variables conditions. So they're only getting the lesson from the stern teacher, or they're only getting the lesson from the friendly teacher. They're not seeing both. They're only in one condition. Whereas within groups design, participants are seeing all of the conditions. Again, that's it. It's just that they're seeing all the conditions of the IV. So to use a different activity number 2 example, if with a within groups design, you have some people drink the sugared lemonade first and then the sugar-free lemonade second. And then, so they're doing both, right? They're getting both types of lemonade, but you would again want to counterbalance to prevent odor effects. So some people get the sugared lemon first and then the sugar-free lemonade. Some people do the opposite, get the sugar-free lemonade first and then the sugared lemonade. So that's all you're doing when you're applying these design tags. You're just saying you're either randomly assigning people to see only one condition, that's independent groups design, or you're making sure people are seeing all of the conditions, but you're counterbalancing. That would be a within groups design. All right, hopefully that was helpful for you guys. All right, next up, let's talk about confounds. So confounds, remember, these are alternate explanations other than the IV for changes in the DV. So remember, in a causal claim, we're trying to make a causal claim, that the IV is causing changes in the DV. The IV is always the thing that we're manipulating. The DV we're always measuring. And in a causal claim, we're trying to say that the IV causes a change in the DV. Confounds are something that get in the way of that. So confounds are an alternate explanation other than the IV, where the confound could explain changes in the DV, not the IV. And that creates a big problem. That's a huge threat to internal validity. All right, so think about this in terms of the possible study. So again, I told you I'm going to use that a lot in this recap video. So in that study, they wanted to show that bowl size, that's the IV, small or large bowl, causes changes in amount of pasta eaten, that's the DV, what they were measuring. So they want to make that particular causal claim. Bowl size causes changes in amount of pasta eaten. But now imagine, this is not in the original study, but just imagine that the experimenter attitude also varied with conditions. So imagine that the experimenter was mean in the small bowl condition and was nice in the large bowl condition. That's a problem. That's creating a confound because it's creating an alternate explanation for the data. Was it bowl size, the IV, that caused people to eat more or less in the DV, right? That's what the researchers want to say here. Or was it experimenter attitude of being nice or mean? The confound, is that causing people to eat more or less? So you can see, imagine if we've got that mean experimenter in the small bowl condition, nice experimenter in the large bowl condition. Maybe people are going to eat more pasta in the large bowl condition, not because of the bowl size, but because the experimenter was nice to them. Maybe if people are nice to us, we want to eat more pasta. You know, it's plausible, right? That's creating an alternate explanation. So it's not bowl size that matters. It's experimenter attitude that causes people to eat more or less. So you can see that confounds are things that can kind of wipe away the IV. It says, well, maybe the IV doesn't matter at all. Maybe the confound is the real thing that's causing that change. The confound is the cause in the cause and effect relationship, not the IV. That's a big problem. That's a huge internal validity threat, because these researchers want to make this causal claim that bowl size influences amount of pasta eaten. But if there's a confound, you can't make that claim anymore, right? That's one of our 3 criteria for causation. We might have covariance, we might have temporal precedence, but if we don't have internal validity, if there's a threat to internal validity like this, that calls into question our ability to make that cause and effect claim. And remember, the whole point of an experiment is to make a cause and effect claim. So if we have a confound, that invalidates our entire study, and it leaves us without anything to show for it. So that's a big problem. Now, in case you're curious how to check for confounds, there aren't objective tests. We don't run a test and say, aha, confound. We don't do that. Instead, we're using critical thinking skills, like thinking through this example that I just gave you for how experimenter attitude could be an alternate explanation. So as researchers, we have to apply that critical thinking to our studies and see whether there are possible confounds that we can identify. And then how to prevent them? You actually prevent them through careful study design. You make sure, in this hypothetical example, you make sure that your experimenters have the same attitude across those 2 conditions. That would be how you prevent that kind of a confound. You make sure you're holding everything constant except for the IV. The IV is the only thing that should be varying systematically in your study. Now, this also touches on systematic versus unsystematic variability, which I'm going to talk about in just a second too. All right, the next money point here was pre-test, post-test versus post-test only designs, when to use each type and the importance of them. So first off, what's the difference between them? The difference between these 2, these are both independent groups designs, right? But the difference is that is how many times participants are seeing the DV. So in a pre-test, post-test design, they're seeing the DV twice. That's the pre-test DV and the post-test DV. And in between them comes the IV. So DV, IV, DV. But in a post-test only design, participants are only seeing the DV once, and it's after the IV, because you gotta have temporal precedence, right? So it's after the IV in that post-test only design. So it goes IV and then DV. So for example, use this example to think about this difference. Imagine that I'm doing a study, I think I use this example in the slides, where I'm trying to see if the type of feedback I give influences mood. I could do that study as either pretest, post-test, or post-test only. If I wanted to do it as pretest, post-test, then I would give people a mood measure first. The very first thing I do is give them the mood measure. That's the pretest DV. So I see what their mood is right now. Then I give them the IV. I give them either positive feedback or negative feedback, or maybe I give them no feedback, right? Say I have 3 conditions there: positive, negative, no feedback. And then I give them the DV again. So I give them the mood measure again, and I look and see, okay, what's your mood now? The advantage of this is that I can look for change in mood from pretest to post-test. If people have the same mood from pretest to post-test, regardless of the IV, the type of feedback, then that tells me feedback doesn't really matter. But you can imagine how whatever mood people were in first, if they get positive feedback, maybe they have a better mood, versus people if they get negative feedback, maybe that makes their mood worse, right? No feedback, maybe it does nothing to their mood. That's the advantage of pretest, post-test design. You can look for change in mood from before to after the IV. I could do that same study, although I could do that same study as a post-test only design. So in that case, the first thing I would do is give people positive, negative, or no feedback. So I dump them right into the IV, and then I give them that mood measure, and I see, okay, what's your mood based on this feedback? That allows more unsystematic variability to play into it because you don't know what their mood was first. So people are in different moods and you don't know what their moods were, so it's a little harder to tell differences based on the IV specifically. But there are plenty of times when a pretest post-test design is impossible, right? And this brings us to our when to use each. So easiest way to think about this of when to use each of these is to ask yourself, will doing a pretest affect the results of the post-test? So if doing a pretest will affect the results of the post-test, then don't do a pretest post-test design. Choose post-test only. And just know that it's going to be your data is going to be a little bit muddier because you're going to have more variability. But if the pretest doesn't affect the results of the post-test, then go ahead and do pretest post-test design, because why not? You have clearer data. So with that feedback and mood example, it would be pretty okay to do a pretest post-test design. You have to worry, maybe people are gonna get suspicious. You might have some demand characteristics. If they know you're looking at a change in mood, that might be a problem. But if you think they're probably not gonna be able to tell that mood is what you're looking at, pretest, post-test, then you might as well do that, right? Because it'll reduce the variability in your data. So again, the feedback and mood example, you could do either way, and if you could do it either way without problems, might as well do pretest, post-test. But some studies, actually quite a few studies, you really can't do as pretest, post-test. Like again, think about that pasta bowl study. Will doing a pasta eating pretest, that's the DV, right? How much pasta you eat, is that going to affect the results of the post-test? So in this case, it would be DV, IV, DV. So it would be measure the amount of pasta people eat first, then give them the small or the large bowl and have them take more, and then measure how much they eat second. You can see that's going to be a problem because after they eat pasta in the pretest, they're going to probably be full. And so trying to do a post-test then, it's going to kind of invalidate that post-test measurement. The amount of pasta they take in the post-test is not a result of the IV in this case. It's a result of the fact that they already did a pretest, and so it's messing with their ability to eat more pasta. So this is not unlike the issue with a within group design. If you're seeing the DV twice, it can create some problems. All right, so the difference is, are you seeing the DV twice or once? And how to think about when to use them is you're asking, does the pretest affect the post-test? If so, like the pasta study, then you better do a post-test only design where they just get the bowls, different bowl size, and then they go eat pasta. And you just have to accept that there's going to be more variability there. Your data is going to be a little muddier. But if the pretest doesn't affect the post-test, like the mood and feedback example, then choose pretest post-test because it'll give you clearer data. All right, another muddy point, a couple people mentioned identifying measured versus manipulated variables. I put this in the key for the activity, but just to revisit it here, what you want to think about when you're trying to decide if a variable is measured or manipulated, you want to think about, is an experimenter randomly assigning people to different conditions of this variable? If so, it's manipulated. So if an experimenter is able to randomly assign people to different conditions of that variable, it's a manipulated variable. And a manipulated variable, that's the IV, right? It's the cause and effect relationship. If the experimenter is not randomly assigning people in this variable, then it's measured, and it's the DV probably. It's the effect in the cause and effect relationship. So you can see the activity key for all of the answers to that activity, but a couple examples to pull out from that. One of the questions was having people complete either an easy or a hard task. This P is, by the way, that's shorthand for participants, in case you're like, what the hell is that? So assigning participants to easy versus hard task, that's something that you can do. An experimenter can randomly assign people to get either an easy task or a hard task. That makes it a manipulated variable. But another question on that activity was measuring whether participants choose an easy versus a hard task. So whether participants are choosing easy or hard tasks, you're not assigning them to choose an easy or hard task, right? You're just measuring which type of task they're choosing, easy or hard. So in that case, you're just measuring it as it occurs. Other things that can only be measured were things like participants' age or participants' height, right? You can't manipulate someone to be a different height. You can't manipulate someone to be a different age. You just have to measure that as it occurs. So when you're trying to determine measured versus manipulated, you want to ask, is the experimenter randomly assigning people to different conditions, or is it something that's just occurring and you can only measure it, you can't manipulate it? So that's what I recommend you think about when you're trying to decide measured versus manipulated variables. All right, I think this is our last muddiest point. So this is the idea of systematic versus unsystematic variability. Someone specifically asked for a video for why is systematic variability a threat to internal validity. So I figured I'd go ahead and talk about all this stuff. All right, now systematic variability. This is a tricky concept, by the way. Systematic variability, that means a confound that threatens internal validity. So when you hear systematic variability, I want you to think confound, because that's what systematic variability is. It's creating a confound. It's something else that's varying systematically with the independent variable and creates an alternate explanation. So that could be like experimenter attitude in that pasta study example from earlier in the recap video. So you have a confound, an alternate explanation, because you don't know whether it's bowl size, the IV, that's causing people to eat more or less, or whether it's experimenter attitude, the confound, that's causing people to eat more or less. And that's because the confound is creating systematic variability because another variable is changing with the IV and providing an alternate explanation. That's the problem with systematic variability. It's varying with the IV. That's what systematic means. It's varying in a predictable way. So in this case, it's changing with the IV. So experimenter attitude, right? They're nice in the large bowl condition and mean in the small bowl condition. That's systematic because it's changing alongside the IV. It's changing at the same time and in the same way as the IV. So that provides an alternate explanation. Now that would be different. It would not be systematic variability. It would not be a confound if the experimenter was randomly mean or nice regardless of condition. So with some people in the small bowl, the experimenter was mean, sometimes they were nice. And in a large bowl condition, sometimes they're mean, sometimes they're nice. That's no longer a problem. That's no longer systematic variability because it's not changing with the IV now. It's changing randomly between conditions. So it's no longer systematically changing with the IV, like it was in the original hypothetical example where they're nice in one condition and mean in another. That's changing with the IV. But in this example now, they're nice or mean randomly regardless of condition. That means it's not a source of systematic variability anymore. It's not a confound. It's just unsystematic variability. All right, now unsystematic variability, I want you to think of that as being individual differences. So whereas systematic variability is a confound, unsystematic variability, that's just individual differences. So that's things like how much you like pasta, how hungry you are. Those things aren't changing with the IV of small bowl or large bowl. You have some people who love pasta in both conditions. Some people hate pasta in both conditions. Some people are really hungry in both conditions, right? It's distributed across those conditions. This, by the way, is the reason why random assignment is so important, because if you're randomly assigning people to conditions instead of letting them choose conditions, you're randomly assigning them instead, then that distributes all these characteristics evenly so that they don't change with the IV anymore. So some people are pasta lovers and pasta haters in the small bowl condition and in the large bowl condition. So it's not systematic, it's just random varying, unsystematic variability. That makes it not a confound, it's just an additional source of variability in the data. It just makes your data a little bit muddier. But again, when you're doing inferential tests, we're accounting for unsystematic variability in those inferential tests. All right, so systematic variability is a confound because it's creating an alternate explanation, changing with the IV. But unsystematic variability, that's just individual differences, not a confound. It's just random variability distributed equally across your conditions. All right, hopefully that was helpful, but as usual, feel free to email me if you have any other questions.